All right, Advent of Code day 2. So I'm challenging myself to live code all of this every day. Advent of Code. If you're not familiar with Advent of Code, it's daily coding challenges. They come out with one every day at around midnight Eastern time. I'm a little bit behind on days. It's currently December 8th, and or is it the 8th? It is the 8th. Yes. So I'm a little bit behind. So I'm probably going to take kind of a brute force approach to this. This whole thing is a little bit weird for me. I don't usually write code like this. I don't usually narrate the code as I'm writing it, and so it's kind of this new mental way of thinking through the solution. And I actually kind of like it. I'm hoping to get a little bit faster at it by the time I'm through here. So let's get started. I'm going to click on day 2. I haven't read this yet. So your flight departs in a few days from the coastal airport. The easiest way down to the coast is via toboggan. It's giving us a Wikipedia link to what a toboggan is. I know what a toboggan is. Come on. The shopkeeper at the North Pole toboggan rental shop is having a bad day. Something's wrong with our computers. We can't log in. You ask if you could take a look. Some of the passwords wouldn't have been allowed by the official toboggan corporate policy that was in effect when they were chosen. Try to debug this problem. They've created a list of passwords and the corporate policy when that password was set. So if we have this following list, a list of passwords. Each line gives the password policy and then the password. So here's the policy. What is the letter here? Password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. 1 to 3A means that the password must contain A at least one time and at most 3 times. In the above example, 2 passwords are valid, so this one has A 1 time, so this passes the validation. This one does not have B in it, so this is the invalid one. This one can have C 2 to 9 times. This looks like it has it exactly 9 times, so that's fine. So the middle one is invalid. These 2 are valid. How many passwords are valid according to their policies? So essentially we have to go through this input and we have to parse out the range of times a certain character, it's a letter, must appear. So let's take a look at this bigger input that we got here. This really, the rules are just this one letter that we get. So there's not going to be a time where we're parsing multiple letters. This is pretty straightforward. So we just have to count the number of times this repeats in the string and then make sure that it's within this valid range. So the approach I've been taking and that I always take is just to do test-driven development. I'm going to create a new day 2 package here. Day 2. And then I'm going to start a class. I'm doing this in Kotlin, by the way. And then I'll also have a link to my repo in the description for this YouTube video. So I'm going to create a new class. I'm going to call it password validator. And this class is going to have a method on it that's going to validate the password, and this will be just a single validation on a password, and it's going to return a Boolean to tell whether a given password was valid or not. And the inputs that it needs to take are the string to validate against, and then the character and the range. And maybe in order to do the range, I'll pass in a start and an end to that range. So essentially what we're going to do is just take this string, take this character, count how many times this character appears in the string, and check whether it's within that allowed range here. So this is going to take, I think, 4 different parameters. We're going to have our test string, which is a string, and then our test, it's not really the test character, it's the input character, which is a char, and then range start, which is an int, and then range end, which is an int. I think I'm going to rename these to min count and max count. And one thing to note is that these are inclusive, as indicated by this. This C appears 9 times, and they're telling us that this is valid, so this 9 is an inclusive range. So we'll keep that in mind. And then I'm going to write to do here, just so the compiler will stop complaining. Looks good. So now we just need to create a password validator test. Day 2. Just creating this package here. Then I'm going to create a test method. Kotlin allows you, I like in my test to just have, I like having spaces in the function names. I don't do this in production code, but I like the readability of having it here. So I'm going to do test first given inputs. And I'm going to use this as an opportunity to read the file for testing. So I'm going to create a new package, or a new directory here, day 2 for the resources. And I'm just going to have my day2.txt here. I'm going to rename this. Oops. Rename this to day2.txt. And we're going to just paste these in. And so essentially we could parse this out with, we can use this spacing to split these strings, and then we'll just filter this character out, this colon. I'm going to create a method, a private fun to parse input. And I think I might even create a thinking of maybe creating a class that's a validation criteria class that this can give us a list of. I might even just refactor this into a data class called password, and then the password has the rules associated with it. Maybe I'm kind of going back and forth. I think I'll do password rules. I'll create a data class called password rules. I'm going to throw this out here. I think I'll keep it. I'm going to keep it as password validator. I'm going to create another class called password rules, a data class, password rules. And this rules class, it's going to be a data class. It's going to have, I'm going to just take these, the input character, and then the min count and the max count. And then I'm going to just pass in the rules, the password rules for this test string. This is going to actually be the password here that we're testing against the rules. Okay, so password rules are going to be val input character is a char, val min count, val max count. Okay, so now this will give us a, when we parse out this input, we can have it give us a list of pair of a character and then password rules. Well, actually, we want the string, and then the password rules. Okay. And then we can pass those in to validate and then get a count of those. So what we're gonna do is copy, I have a get inputs here. I'm gonna just copy that to start off with. I'm gonna pass in a file name, which is a string. Reader, read lines, and then we're gonna map it to this method per line is going to, I'm going to create a separate method that's private called parse line, and that's going to just take a line that's a string, and then that's going to give us back a pair of string to password rules. Okay, so given a certain line, I'm going to split IntelliJ vertically here so we can see both of these. Day2.txt, let's take a look at the formatting here. The first line is going to be the range, so it's going to be like the min and the max, and then the char, and then the password. So initially what we want to do is line.split, and then we're just going to split using a space. That first index of this list that it gives us back is going to be the range. So then we can go val range raw. I'm going to say range is equal to line. First I have to do val split line is this. The range is going to be this split line, the first one, and then we're going to split that by this minus character. And so that range, we now have this 1 in the 0 position in the array, and then the 3 in the 1 position. So that's good for now. And then val input char is equal to split line. It's going to be this one. And I think we can just grab the first character in it. Right? Does that give us a... That gives us a char. Okay, so we're set. So we know this first character is always going to be the letter. Okay. And then we can just grab this is going to be the password here. So what we can do is we'll return a new pair. The first one is going to be the password, which is split line, and then that's the 0, 1, 2, the second index, and then the range. We need to create a new password rules, and this is going to be input char, the range dot the 0th index of the range dot to int, and I'm going to just put these on separate lines so it's cleaner. And then the 1 index of that range to int. So that gives us the rules and the line. So let's just make sure that, and then I'm going to map this to parse line it. And that will give us this. So I just want to make sure that this is copacetic. And I'm going to go through and parse input day2.txt, And then it doesn't matter what I put here. I just need some extra lines. So I'm going to just do print ln inputs. And I'm going to set a breakpoint here, and I just want to sanity check this to make sure that I parsed these inputs correctly. My inputs. So I'm expecting this first one, ABCDE, is the password. Cool. And then the second one, input character is A. Yep. Min count is 1. Max count is 3. Yep. C, D, E, F, G. Yep. And then the second one, B. Yep. 1 and 3. Yep. And then the first one, 9 C's. Second, looking good. 2 to 9. Perfect. Boom. Okay. Now we got to validate these inputs. So, given this validator and this set of rules, we want to count the number of occurrences of this input character in the rules that we have in the string, and then determine whether it's within that range. Should be pretty straightforward. So, cool. Okay, so count if it equals rules dot input character. Okay, so that will give us an int representing the count if the character in the password is this input character. So I'm going to call that val count equals this, and then we want to return whether count is greater than or equal to the rules dot min count, and it's less than or equal to the max count. And remember, that's an inclusive range, as we saw. And that's it. I think we're set there. And what they want, I think, is the count of valid. How many passwords are valid? So it's just the number of passwords that are valid there. So in our test, we can just do inputs dot sum by, and I think I'm going to change this. This password validator doesn't need to store any state. And so in Kotlin, there's something called an object, which is essentially a singleton. And we'll just use that. So we can call this method statically on it. So I'm going to do password validator dot validate. And remember, this is a pair here that we got. And I think does this take a predicate? This is a selector. I don't think this is the one that we want. Dot count. I think I can do count, and then there's a predicate. Okay, cool. So we want to do count. We're going to validate, and then we have a pair here, and we want to validate based on the first one as the string, and then the password rules. So we're going to do it dot first, it dot second, and that inputs dot count. We're going to save that to a variable equals this. And we want to just make sure that the count should be 2 in this case. And we want to make sure that, so this one is the invalid one, right? So I'm going to set a conditional breakpoint just to sanity check my code here that it's password validator. I'm going to just go line breakpoint. I'm going to do condition. I'm going to make this rules dot input character is B, and we want to make sure that this is the invalid one. I'm going to run this in debug. Should hit that breakpoint once that is there, and we're expecting this to return 0. which will be less than the min count. Okay, so C, D, E, F, G, so 1, go there. The count is 0, and then I'm just going to evaluate this on the spot here. The result is false, so it's flagging that as invalid, and our test passes. Okay, cool. So now we can go to work and validate the rest of the input. I'm going to close out this split pane here. Okay. Now I'm going to test full inputs. I'm going to make a file called day2full, and I don't know what the count is yet, but what I'm going to do is do a println count, and then I just need to create that full input, day2-full.txt. Go over here, grab the puzzle input, and let's run it. $500, which should be about half of these. I'm suspicious of this number. It seems a little too perfect, but let's see. That's the right answer. All right, part 2. To try to debug the problem, they have created a list, your puzzle input. I'm actually going to go back and just add that as a test condition here. So I'm going to do count should be 500. There we go. Okay. They have created a list, your puzzle input of passwords according to the corrupted database and the corporate policy when a password is set. Oh wait, this is part 1. I've already done that. Part 2. While it appears you validated the passwords correctly, they don't seem to be what the official Toboggan corporate authentication system is expecting. The shopkeeper suddenly realizes that he's just accidentally explained the password policy rules from his old job at the sled rental place. The official Toboggan corporate policy actually works a little differently. Describes 2 positions of the password. 1 means the first character, 2 means the second character, and so on. They have no concept of index 0. Okay, so they're indexed at 1. Exactly one of these positions must contain the given letter. Okay. This one's valid. Invalid, neither position 1 nor 3. 1 and 3, okay. 2 and 9 contain C. Okay. So we can effectively do the same thing. The parsing of the input will work the same way. I think I'm going to create separate classes for this part 2, given that it's a different implementation of this. So let's do part 2. I'm going to call this part 2 password rules. rename that. I'm actually going to suffix it with part2 just so it's more readable. I can look it up easier. I'm going to create another password validator for part2. And then password validator part2 test. And we'll leave these tests for the given inputs. We are going to change this over to password validator for part2 here. And then this parse input is going to be password rules part2. We're still going to parse it the same way. Password rules part2. I'm going to call these indices. Lower index and upper index. And now, effectively, we just need to rewrite the validator. This just needs to take a password rules for part2. And now, we don't care about the counting. This is exactly 1. But other occurrences of the letter are irrelevant for the purposes of policy enforcement. So I'm just parsing what this means. I think it doesn't matter. So if A is at both positions 1 and 3, it doesn't matter. Oh, here's an example that they give us that, okay, so both of these contain C. So you need to have it's exactly once. It's not at least once. It is exactly once. Okay, so we'll keep that in mind. And I think what I'm going to do is I'm parsing this. I'm going to normalize it to be 0 indexed here, just so I can have the validator more easily parse it. I'm going to subtract 1. So we're going to just assume that this is 0 indexed. I'm going to make a note of that in the docs. Assume, actually, I'm going to put it in the password rules part2. So normalize these first. Okay, cool. So we want to make sure I think we still want to do a count of occurrences at those positions. So this password I'm going to create a var count, make it 0. And Kotlin has this, Kotlin can actually return stuff from an if statement. So I'm going to check both indices, and I'm going to add 1 to the count if it contains that letter. So this is going to return a char. I'm going to do count plus equals. So this is first going to check lower index. I'm going to call it count lower index. Count plus equals, and then if password rules.lower index is equal to rules.input char, then we want to return 1, else 0. I'll do the same thing. And then we want this count to be exactly 1. I'm going to do the same thing again just to do a sanity check on this. I want to make sure that this one that they said was invalid is, I want to make sure that these are both invalid. So I'm going to check this B one first and then the C. I mean, I could just run, there's only 3 inputs. So in this case, count should be 1. I'm just going to walk through this for every one of them. Password validator part 2 test. I'm going to debug it. This is the case where A, B, C, D, E. Let's split this again. Vertically open up my input. A, B, C, D, E. That one is valid, which is what we said, right? So this is at 1. There's an A. Okay, so that's valid. This next one should be 0, which is not. Was that what we were expecting? So this is B. We're checking 1 or 3. 1 or 3. Okay, so there's no B. And then the next one we're expecting the count is going to be 2, right? So count is 2 here. It counted the lower and the upper index, and then the test should pass. Okay, so now the full input, we're going to do the same thing where we're just going to print the count, comment this out, test the full inputs here. All right. That gives us 313. And we got it. Sweet. Well, cheers. Day 2 is done. I'll see you next time.